right, welcome back. Last time we talked about the brake packet. We finished up all of the perimeter and area stuff. I want to just briefly touch on number 3 and how important it is using sine and cosine, and then number 5 using a squared plus b squared equals c squared. You will see that coming up in our next unit. For now, though, I want to go on to this guy where we talk about the weirdo who was stroking the pottery. You should have at least tried these. Let's take a look at what we should have done on them. So we've got an equilateral triangle continuously rotated around one of its medians. Medians means midpoint to the opposite angle. So midpoint to the opposite angle, it's being rotated. So draw our little circle, circle all the way up, and we get a beautiful cone. This one, rectangular below, constantly rotate around W. So we need to draw in what happens when W gets reflected, and then draw massive spinning around. So we spin that sucker all the way around, and we should be getting a nice cylinder. Notice we basically have a rectangle plus a circle. Rectangle plus circle equals cylinder. Well, no, it can't be a cone. Cone would be a triangle and a circle. It can't be a pyramid. Pyramid has nice straight edges. And a rectangular has straight edges. There's no circles. When it says spinning, there needs to be circles involved. Yeah? So for this one, when we rotate this guy, we're going to rotate it around RS. So we reflect it on RS. Yeah, we got to reflect it, and then we're going to spin it. It is. It's exactly like the first one, so we get a cone. Student has a rectangular postcard. So we've got a nice rectangular postcard. He folds it in half lengthwise, and he rotates it. So we're rotating it around, and yes, squirrel is right. It is. It's exactly like 2. Yeah, so you get a cylinder. That's exactly what happens. All right, next one. We start talking about cross sections. Cross sections are when we chop things up. We're not going to chop up a squirrel, though. That would be cruel. A plane intersecting a hexagonal prism. Hexagonal prism. Let's take a look at what a hexagonal prism looks like. Perpendicular to the base. So the base is the hexagon. A hexagonal prism has a base of a hexagon. Yeah, because when we do our volume, we're going to do V equals capital BH. Well, capital B has to be that hexagon. So we want perpendicular to the hexagon. Perpendicular to the hexagon means this guy. So we're going to get a nice rectangle out of that. Cross section of a regular pyramid. Regular pyramid is over here. Also heard of a rectangular pyramid or a square pyramid. Contains the altitude of the pyramid, so that's the height of the pyramid. So we're chopping it this way. If we're chopping it that way, then we must be getting a triangle. William is drawing pictures of cross sections. Which one cannot be a cross section? Okay, well, if we're cutting it down like this, we get a triangle. So this can't be a triangle because triangle works. So let's take a look at, okay, if I cut it like this, I would get an oval, so oval would work. Now, if I cut off just this piece right here, if I cut off this part right here, shear that off, that's going to get this piece. There is no way to get a rectangle. Notice if I cut it down here, like this, cut it here, all the way across down there, that will get me the curve on top, and it'll get me the bottom right there. But there's no way to get all four sides to be nice and straight all the way across. So it's not possible to get a square out of a cone. Which figure can have the same cross section as a sphere? Sphere is a bubble? Yeah, so all cross sections of a sphere are going to be what, squirrel? What are the cross sections of a sphere? Sphere is basically a what? She doesn't know. It's a circle. So we're looking for which has the circle cross section. Circle cross section, going to be from our cone. It's the only place where we can get a nice circle cross section. Okay, let's take a look at perimeter, area, and volume. As shown in the diagram below, a regular pyramid has a square base of 6 inches. If the altitude means height, is 12, so from here down is 12, we want the volume. So volume equals base times, 1/3 base times height. Good catch, squirrel. So 1/3 base times height. So our base is going to be that square. Yeah, it's got to be that square down there. So base equals little b little h, 6 times 6, also known as 36. Yeah, so now we need to plug that into the big formula. So 1/3 of 36 times 12 is our height. Good job. Times 12 is our height. That's going to get us 144 as the volume. Good job. Okay. Number 2. A water cup in the shape of a cone. Well, that's a poorly planned water cup, but okay. Okay, I've seen cone-shaped water cups before. They do exist. Has a height of 4 inches, a maximum diameter of 3 inches. What is the volume to the nearest 10th? Yep, so volume equals 1/3 pi r squared h. R is going to be, 1.5. Whoa, squirrel. R has to be 1.5 because it's 3 across there. So we're going to have to do 1.5 and an h of 4. So that's the height is 4 inches. So 1/3 pi 1.5 squared times 4. And we're going to type that into our calculator. Now, we would do that and we would be fine. Unfortunately, we would be wrong. Yeah, as Squirrel said, this is not correct. She tried to warn me and I said, you gotta calm down. This is when the cup is filled to half of its height. So half of its height means we're going to be down here. And if we look, we just hit a similar triangle proof. Yeah, we did. That's similar triangles. So this is 1.5, and the height starts at 4. When we cut it in half, this goes down to 2, and this guy goes all the way down to 0.75. Yeah, 0.75 right there. So when we do my volume, the volume is 1/3 pi 0.75 squared times a height of 2. Notice those are good similar triangles in there, with this big side being 4 and this big side being 1.5, and then us having to find the littler sides. And when we type that into our calculators, we get 1 as our answer. Good job, squirrel. Next one, we've got a fish tank in the shape of a rectangular prism. Okay, fish tank, rectangular prism. Nice rectangular prism right there of 14, 16, and 10. So 16, 14, and 10. Okay. Tank contains this much inches of water. What percent is empty? Oh, goodness. Okay. So we need to find the volume currently. So 14 times 10 times 16. Let's figure out what the total volume would be. If we figure out the total volume is 2240. So that's how many cubic inches of water there could be in the tank. But it's only filled to 1680. So 1,680 are filled out of the 2,240. Yeah, that's going to tell us the percent of filled. So the percent of filled is at 75% filled. It's over half. But is that the question? The question asks how much is empty. Well, if 75% of it is filled, 25% must be empty. Go figure, right, Squirrely? Next one, tennis balls are sold in cylindrical cans. So we've got a nice cylindrical can right here with balls stacked one on top of the other. So we've got a stack of 4 tennis balls. 1, 2, 3, 4 tennis balls. Tennis ball has a diameter of 6.7. So 6.7 for just that one tennis ball. And we need to figure out the volume of the can. Okay, well, if that's 6.7 for one of them, and there are 4 of them, that gives us 26.8. That sounds about right. And then this is a diameter, so that's 6.7, which means the radius is going to actually have to be half of that. So that would be 3.35. And we go through and do our volume. Volume of a cylinder is pi r squared h. So pi 3.35 squared and then 26.8. Type that into our calculator and we should get 4 as our answer. Okay, so that's how we're doing with the volume. Let's take a look. As we get further on with these questions, there are going to be more and more questions that you have to think through. How does this work? Why does this work? And all of that good stuff. So let's take a look at this one. We've got a solid metal prism, and then we've got a hole in the shape of a cylinder, and we want to find the volume that's left over. So first thing that we need to do is we need to find the volume of the rectangle. So that would be 4 times 4 times 6. Yeah, that would be 90, not 96. What are you doing? That is not 96. No, it's not. Is it? You sure? All right, I'll go with 96. If you're really sure on that. You did that in your calculator or in your head, Squirrel? Okay, volume of a cylinder. So volume of the cylinder is going to be pi r squared h. Our r is 1. It goes all the way through the block, so 6 is going to be our h. So it's going to be pi 1 squared times 6. Yeah, basically pi times 6. So that's going to get us 18 something, 18.8496. Okay, now notice, if you had just gone with the 96, that's an option. That's not the correct answer. If you had just gone with the 18.8, that's also an option. It's not the right answer. What you have to do is you have to take those two numbers and we're going to carve out this hole. So we're going to take the 97 or the 96, we're going to subtract the 18.8496. Yeah, we have to subtract it because we're drilling out a hole. When you drill out a hole, you subtract it. And that's going to get us 77.15, which is an answer. Good job, Squirrely. It is an answer. It's very important. Okay. A company is creating an object from a wooden cube with an edge length of this. Okay, so we've got a cube. Draw your cube. Edge length of 8.5. A right circular cone with this and an altitude of this is cut out of the cube. Okay, so we've got a nice cone being drilled into the cube. We want to know which expression is remaining. Okay, so the first thing that we have to do is we have to take the cube. So the cube volume is 8.5 times, oh, well, this is 8.5 and this is 8.5. 8.5, 8.5. So we start with 8.5 cubed, which, hey, it is right here. All of them say 8.5 cubed is where you should start. Good. And then we subtract, and all of them say subtract. Good. The next part is we need to talk about the cone. So the cone is going to be diameter of 8, altitude of 8. Well, the volume of a cone is 1/3 pi r squared h. Well, these guys don't have the 1/3 in it, so it can't be 1 or 2. Diameter of 8, so we need the radius of 8. So it's 1/3 pi, radius is 4 squared, times an altitude of 8. So that's number 4. And that's how we do that problem. Let's go to the next one. Great Pyramid of Giza was constructed. And we're going to draw that Great Pyramid right here. Draw a beautiful pyramid. It's gorgeous. We've got a nice square base. We do not know the sides of the base. We know the height, which is 146.5. And we want to find the, oh, we have the volume. We want to find the side of the base. Okay, so we start with the base. Volume equals 1/3 capital base times height. Capital base is going to be base times height, because we're looking at this square down here. So x times x. So our volume is this, 2592276 equals 1/3. Base is x times x times h, which is height of 146.5. Menu 31 that sucker, and you get that for your answer. All right. A candle maker uses a mold to make candles like the one shown below. So we're looking at, looks like a cone right here. Height of the candle is 13 centimeters. The circumference is, it's giving me C equals 31.416. And we need to model approximately how much wax we need to make the candle. So it wants to find the volume. Okay. So in order to find the volume of a cylinder, we need to do volume equals, for a cone, 1/3 pi r squared h. Well, we've got h. H is 13. So we got 13. R squared pi 1/3 equals V. Okay. We have the circumference. So what we're going to need to do is we're going to need to work backwards from that circumference. Circumference is equal to 2 pi r. So we're going to take this 31.416 and we're going to set that equal to 2 pi r. And then you can menu 31 that to figure out what r is. And if you do end solve on that, or just divide by 2 and then divide by pi, you would find out your r is about 5. So I can go in here, erase this, and put 5 in there. And that will get me my volume. And once we type that into the calculator, we get about 340 centimeters cubed of wax. So we have done all of these. Number 9, very important if we had a Regents exam. Since we do not have a Regents exam, I am going to cross out number 9. Number 9, extremely, extremely important because it talks about similar triangles and it goes on with that, but I'm not going to force you to do number 9. Number 9, not necessary. For our next video, we are going to delve into what happens when we add in density to this volume. We've done a lot of volume problems in this one. We've talked about volume. Now it's time to add in the density, which means another unit conversion at the end. So that is all I have for today. Tune in for my next video. My next video will be on Thursday when we learn what happens when density gets added in. Thank you very much and have a wonderful day.